Hello, welcome to Being Techie. This is the next session in ASP .NET Core series. Today we are going to talk about logging. Logging is one of the important features for any application. It provides a way to analyze and debug the issues during the development as well as in production. Today I'm going to explain what kind of support is present in existing .NET framework for logging and in the new .NET Core framework. If you look at the old .NET frameworks, there was no support in terms of high-level logging classes. The base of any logging is through trace listeners. Remember, we have system.diagnostics namespace and the assembly. So that trace listener directs the output to standard output. And there are various high-level frameworks primarily created by third party, and within our applications we use those frameworks to log our diagnostics. For example, log4net. And to use those log4net classes, we within an application create our own abstraction similar to iLogger manager iLogger. For example, iLogger manager provides an ability to create a logger which is of type iLogger, and within iLogger we have different methods like log information, log error, log exception. So these are the kind of things developer used to write apart from the application logic, which is not really necessary. This is a logger abstraction. So in the new framework, in the .NET Core, this abstraction has been given in the framework itself. So in the core, we have a new NuGet package, Microsoft.extensions.logging, and it provides a two main interfaces, iLogger Factory and iLogger. And these logger providers are not just restricted to console and debug. There are NuGet packages which provides log support for third-party logging frameworks as well, such as nlog, log4net, serilog. Each one is defined in a separate NuGet package. So in this session, I'm going to explain how in a ASP.NET application, for example, like a web API application, how a logger factory and iLogger class can be used to log a sample message to a console. Let's start with the sample. I have already created a default ASP.NET application using a web API template, and there is a controller called employee controller with few endpoints. So to set up the logging, let's go to startup class. Inside the configure services, we want to create this logging factory as a service so that this factory is available in each and every controller, and every controller upon instantiation creates its own logger specific to that class name. I'll explain you like what is the advantage of creating a separate logger instance for each controller. So let's add a class iLogger factory new logger factory. Factory cannot simply log unless there is a provider. So there are some built-in extension methods which provides logger providers. Add console, add debug. Ideally, the default one is add provider where you explicitly provide the logger provider, but the console debug are the extension methods which takes care of instantiating the actual provider. I'll go with the console so that I can show you the logging messages during the debug. Once a factory is created, we should make this available for the dependency injection. Services dot make it as an add singleton, which is of type ilogger factory, and pass the instance we just created. So this piece of code makes a logger factory available for each of the controller or any class, repository or a business logic for anything. And creating a logger out of this factory will provide a console logger. So let's move on to the employee controller. Make sure we get that logger inside this constructor. Include the namespace. I'm going to have my own local logger instance particular to this controller. Instantiate the logger for this controller class. We use a method called create logger. If you observe, I'm going to use a generic create logger method passing a current class name. This has an advantage during the log. Now get into this actual endpoint. Just for a demonstration purpose, I'm going to log an info message employee get endpoint is called. Let's debug this with a breakpoint on the logger itself. And clear the debug window. Oops, this did not log anything. I think something is wrong with the logging setup. Let's see what the issue is. Let's go to the log setup. Here we are logging to a console. Let's make it as a debug. Since we are looking at the debug output, and now run the same sample again. Again clear the log. F10. Yes, this time it logged properly. It has three parts to it. One is the actual information being logged, and the level of information. Here in this case, it is just an info, and the class in which it is logged. This is another important one for debugging purposes. It shows like where exactly the log happened. And this is coming from the type parameter we passed in the create logger. And there are multiple ways this message can be displayed, which which can be set through message filters while creating the logger itself. So this way, the new .NET framework provides a built-in support for the logging abstractions. So in this example, I have shown the a debug logging. Now this can be extended to any kind of framework, for example, Log4net, nlog, or anything, or even our own custom logging if we implement this iLogger factory and iLogger. And the rest of the code will not change. Only the setup will change. Even this setup we can move into a configuration so that dynamically we can change what kind of logging should be added to our application. So this is a flexible functionality added by .NET Core framework for all the developers. I hope you enjoy this video. See you next time. Thank you.